So chapter 9 is a really weak chapter. That's one of the reasons I wanted to do commentary, is just to kind of provide an excuse for each of these chapters that are so terrible. I was in a rush to do this book. I wrote it in about 6 months. And that's actually 2 versions. I wrote like 3 to 4 chapters. I had 3 to 4 chapters pretty well complete, like several hundred words or several thousand words per chapter. And I had to start over. And so I started over. The reason I started over is because I wanted to use LaTeX instead of Word. And I just didn't like the way that it was going. I started off with observational evidence. That was going to be the first chapter. And I realized that observational evidence is this very interpretive thing. Like basically every piece of evidence that has ever been discovered is in support of lambda CDM. And it's just part of the publishing process. And what I mean by that is that publishers will rarely publish anything outside the paradigm or anything that challenges the paradigm. And there's good reason for this. You want to extend the map rather than redraw it. When you redraw something, like when you recreate a paradigm, it takes a lot of work to get it going. You've got to get everybody on board. And once you have everyone on board working on this one thing, you don't really want to shake the boat. Even if there might be a reason for a paradigm shift, you kind of want to keep that reason subsurface level. Like you want to expose it in a way that uses your current map. And I think that's what cosmology has done. I'm extremely critical of cosmology, and I'm extremely critical of the publishers. Like they're all, man, it's a disaster. It's a complete and utter disaster. But in hindsight, I have this opportunity to be able to analyze it in like looking back. Like I can turn around, I can look in my rearview mirror, I can see what's going on behind us. Like I'm not going to change anything. Like no one's ever going to listen to this and be like, oh yeah, the universe is not expanding. It's going to take a long time. It's going to take 100 years probably before humans come around. Because the difference between gravitational redshift and expansion is, I mean, like it's they've painted themselves into this weird corner where they can just stay for a long time. And the only way to get out is just to walk across the paint. And they don't want to walk across the paint. They've packed lunches and everything. And there's not much of a difference, honestly, because once they get in the gravitational redshift corner, then it's like, I don't know what happens. Like, it's not much of a change. It's not much of a change. We go from a universe that is limited in age to a universe that is unknown in age. A universe that is expanding from a central point to a universe that has we don't know how it started. So we actually know less this way. Now, the Big Bang Theory is pretend. We're pretending to know that something happened, but it doesn't matter. The pretend doesn't really have that much of an impact, I don't think. I mean, it has a little bit of it. People should know this. Everyone should know that the universe is infinite in space and time in all directions. But it doesn't change much. It doesn't change much at all. Like I've thought about it, and like it's, it plays a bit of a role in Fermi's paradox, to where you would think that aliens would have visited, but more than likely the answer is if there are aliens, they probably have visited. But we've only had the modern world for a couple hundred years, so at any other period, if they visited, we wouldn't know about it. And so, that's the solution to Fermi's paradox, is the timing was off. And they probably wouldn't mess with us. We probably wouldn't do the same. If we saw another planet with people on it and say they were driving cars and had satellites, we may not interfere with them. We may not want to because we don't want to go to war with people, like especially if you study them for a little bit. You definitely study them before interacting. And if they're anything like humans, then you may not want to interact with them. So there are some philosophical consequences that arrive from this. But as far as observational evidence, it's difficult. It's difficult because Lambda CDM has already claimed credit for almost all of the observational evidence. The CMB, the cosmic microwave background radiation. This model explains it so much more clearly. There's so many, like there's only one parameter. And it's not even it's an empirical parameter. So it's not even adjustable. It just depends on what the evidence says, the observational evidence, and that decides this entire model. And that is, you could even put it straight to the holographic principle and say that it's the surface area or the surface density of the universe, the surface density of the universe. And then that decides the amount of redshift, that decides the temperature of the CMB, that decides the lower scale, that decides the upper scale, the horizon. So it's all set by that. It probably sets the speed of light. I'm not sure. I've worked on that. I don't know. Whatever. So in addition to creating a cosmological model based on one data point, we also can demonstrate that the universe is not homogeneous, and so you therefore must use a density profile. This is because mass density is a scale-dependent variable. You must use a scale-dependent profile. The reason for this is that in order to determine the amount of gravitational redshift from starlight, you have to use a scale-dependent potential in order to determine the null geodesic, the total geometry for the null geodesic between the observer and the emitted. And once you do this and you account for the realistic distribution of mass instead of just claiming it's all the same mass density, the moment you fix this, you have a distance proportional gravitational redshift, which can be aligned with the Hubble's law. And so in other words, because the mainstream has ignored gravitational redshift, they're now in a corner to where this gravitational redshift would exist in their model as well. So, in other words, you can't say that it's all expansion. You would have to say that at least some of this is gravitational redshift because it's going to be distance proportional. And so once you include the distance proportionality of it and admit that there has to be a scale dependence to all starlight observations, once you admit that, you have to subtract something from Hubble's law. You have to say, well, it's no longer expanding at a rate of 72 kilometers per second. It's now expanding at 50 kilometers per second, or whatever portion of gravitational redshift you want to admit to. But then this breaks your paradigm. And so that's what I'm leaning on. We don't need to talk about observational evidence because the current paradigm is broken and it must be replaced. My suggestion is that it was wrong in the beginning. Expansion was never a possibility, not without some enormous amount of energy to add. And so we're back to general relativity. We just use general relativity instead of the cosmological standards The cosmological procedures and methodology has been wrong. It has been invalidated. And so there is no reason to compare observational evidence. We need to revisit observational evidence under a realistic paradigm where we don't have some unformed, mysterious energy that is dominating everything and prevents us from making any conclusions. It was just a big, giant mistake. Anyways, this is hindsight. And the reason I know this is because, like I say, you take one data point. What is the surface density of the universe? That is your density profile. It produces Hubble's law. It produces a horizon. It produces the CMB. It produces a lower scale length, a lower scale length and a lower energy scale, a lowest possible energy scale, and an upper, the largest possible energy scale, the highest. And really, the only reasoning you have to do to get to that point is just admit that mass density, that density equals mass divided by the volume. That's all you have to do. Once you admit that, then the current paradigm fails, and this is the paradigm that arises. And so we don't need observational evidence. I mean, we need observational evidence. I didn't mean it to sound like that. I'm just saying that observational evidence is not as, I don't know what to say, really. I mean, observational evidence is very important, but the interpretation is more important. And if you just claim the cosmic microwave background radiation is evidence of a Big Bang, then, you can do anything. You can claim anything as evidence of a Big Bang.